Hi, everyone. It's great to see you here. Hope you had a great lunch. My name is Ben Gable. I'm a game developer and developer advocate here at Google. I work with game developers to help them make great games on Android. And today I'm here to talk to you all about a topic that I find very personally interesting, and that is adapting Android games beyond the phone. So it wasn't too many years ago that when somebody said mobile gaming or Android gaming, you'd think of a device like this, right? And everybody knows what this is, right? It's a phone. So you've got a touch screen, you've got an accelerometer, gyro controls. Resolution and aspect ratio are pretty standard across all of them. But I'm here today to tell you guys that Android gaming is not just phones anymore. And the Android ecosystem is constantly evolving, and Android now not only runs on phones, but things like Chromebooks, tablets, Samsung, or desktop extension technologies like Samsung DeX, and coming very soon, the world of foldables. So tons of OEMs are working on foldable devices. You might have heard of the Samsung Galaxy Fold. So as game developers, you guys need to start considering what kinds of devices that your players are going to be experiencing your game on. It could be a phone in portrait mode. It could be a Chromebook or DeX device with a keyboard and mouse attached. Or pretty soon, it could be a foldable with two screens that are changing the resolutions when they open up the device. So maybe I want to get a quick show of hands of how many of you have actually thought about this problem and maybe have a game that you've optimized for a game or for a device that's not just a mobile phone. Show of hands. OK, not too many, so that's good. Hopefully, you guys learn a lot today then. And this is really important because as game developers, right, we want to provide the best possible gaming experience for our players, no matter what device they happen to be playing it on. So as gameplay continues to evolve, not only devices are evolving, but we're seeing the gameplay evolve as well. So mobile gaming isn't just hyper-casual, one-button, one-touch games anymore, right? We're seeing these gameplay designs that mirror something you'd expect on like a PC or a console with longer playing sessions, more advanced controls. And so people like me and many others want to play these types of games on Android in a way that I would expect to play it maybe at home on a console or on a PC with a keyboard and mouse. And not only that, but maybe I want to see it on a bigger, more beautiful screen. I want to avoid kind of the hand claw of playing my favorite MMORPG for many hours on end. And it's not just about providing the best possible experience. It's also about reach. One of the key themes of the gaming keynote this year at I/O, which I don't know if you guys saw it, was about reach and reaching more players. And so gamers, the number one thing that we hear from our end users are that they want to play games on these devices. And our friends at Gameloft actually found this out firsthand. So they have a game, Asphalt 8, and they saw that people were playing it on a Chromebook. And so they went in and we worked with them to kind of optimize the controls and some of the UI elements to suit these larger screens. And what they found is that after they optimized it, they saw a 6x increase in daily active users and a 9x increase in revenue, just for the Chrome OS version of the app, not against mobile. So this just kind of goes to show that players want to play these games on these other devices. And so it's really important there is a desire to play across all these different classes of devices. So let's kind of go over overview of what each of these kind of classes are. So starting off with Chromebooks. So you might know Chromebooks as laptops, but the operating system, Chrome OS, now runs on many different kinds of devices. We've got all-in-one desktop boxes, you've got detachables, you've got tablets now like the Pixel Slate. There's a variety of inputs usually associated with Chrome OS, but the primary input devices are keyboard and touchpad. And as you know or may not know, Android runs inside of a container on Chrome OS. So the full version of Android is running inside there. And to your game, it's essentially running on an Android device. It's just that it happens to be connected to a larger display device, and maybe it has inputs attached. So what we found for a lot of developers is that 90% of their game is probably running on a Chrome OS device right now if you go and download it. And the last 10% is just really easy, small tweaks to make sure it's fully optimized for that hardware. And Chromebooks are growing. So we saw that it reached 26% market share last year. And year over year, the market is growing 77% for Chromebooks, according to NPD. So Google's put a lot of effort into growing the Chromebook and Chrome OS line, and gamers are continuing to buy these devices, and they want to play games. Tablets. Tablets have been around since Android Honeycomb, long time. And now you've got a wide variety of tablets, everything from the Pixel Slate, which is more, I would say, high-end, to more affordable devices and other premium tablets like the Galaxy Tab S4. And tablets remain a huge portion of kind of what we think of as this mobile gaming space, right? So according to NPD, last year, 19% of all active mobile gamers were playing on an Android tablet. And that's across all mobile platforms. So as you can see, there's a large group of players there that are active and want to play games. Third, desktop extension technologies. So more and more we're seeing mobile devices, like a lot of Samsung devices, come with technology that allows you to connect it to a larger display, to connect things like a keyboard and mouse. And actually, it is not just the Android OS with you've got a full screen app, but it actually simulates a multi-window environment where your game window can be resized and dragged around. So it's much more like a desktop experience than what you'd expect from Android on the phone. And as I said before, coming very soon are foldables. So we've got tons of OEMs that we know are working on foldable devices. And there's going to be a lot of interesting use cases with the smaller outer screen opening up to the larger inner screen. So this is something that you guys are going to have to think about as well, coming very soon. Now, I realize the words new platform are kind of scary to a lot of game developers. And there's already a lot of challenge, right, on supporting all of the device fragmentation on Android. But what I want to stress here is that this is all still Android. And by following the Android best practices, which I'll talk about today, you're going to get a great baseline experience across all these different devices. Now, there are obviously more targeted things you can do for specific devices and form factors. But today I'm just going to focus on the stuff in the middle there, the best practices. They're going to give you the best overall compatibility, no matter which device your players are going to be playing on. And you can do this all with one APK. And it's possible. You don't have to do multiple APKs. You don't have to try to fit everything into one APK and stay underneath some size limit. This is all possible with one APK. And it starts with kind of changing your mindset. I get it. You're in development. There's features that have to ship, deadlines that have to be hit, patches that have to be pushed. And it's very easy for developers to kind of start thinking about devices as, I've got to fix this bug for these devices. I've got to improve performance for these devices. But as engineers, we're kind of taught to be adaptive and anticipate changes and make sure we handle a wide variety of scenarios. So I realize in the fast pace of game development, it can be very hard to think about that. But for supporting all these devices, the key thing I want to stress is to anticipate changes and be adaptive. And for example, you might change your assumptions that you're not just playing on a small screen with a set resolution. You could be playing on a laptop or a larger display screen with a much different aspect ratio and resolution. You might have a touch screen. You might not. You might have a controller attached or keyboard and mouse. You might have accelerometer. You might have a gyro available for input. And you might be playing on something from a low-end phone all the way up to a gaming-capable, high-performance Chromebook, for example. So it's really important to kind of get rid of the mindset of you're just building one APK for a certain set of device with a certain set of assumptions, and build an APK that can adapt and change no matter what environment it's running in. So luckily, in Android, if you're not aware, there's this concept of configuration changes, which is the method by which Android tells your game and your activity about things that have changed with the environment you're running in and that you might care about and adapt to. So there's lots of different configuration change events that are getting thrown around in Android when things happen. For example, if a keyboard gets attached or detached, if the orientation of the screen changes, or maybe the screen size resolution changes as well. And so by default, what's going to happen is the Android OS is sitting there, and it's listening for any of these configuration changes. And what it does by default is It'll ask you to maybe save your game state. It'll give you some method to kind of save custom data. It's going to restart your activity, and then it's going to restart it and give you back the data that you saved to try to re-instance and go back to where you're at. However, for a lot of resource-heavy applications, and especially games, we do not recommend that you let the Android OS do this for you. Because in some cases, you can get lots of configuration change events, even across a couple of different frames. So for resource-heavy games, restarting the activity and reallocating all your resources is going to slow down the system, it's going to slow down your game, and it's not going to give that seamless experience that you want when players are switching between different configurations. So there's another way in which you can handle configuration changes, and that's through handling them yourself in your code. So in your manifest, you can simply declare all these different configuration changes that you want to handle yourself, and then in your activity, it's going to, instead of restarting your activity, it's going to invoke onConfigurationChanged. And it's going to give you the new configuration that you're running in. So now you can do things like scale your UI or your OpenGL content to match the new resolution. You can toggle your control scheme to adapt to some input device that was attached or detached, et cetera, et cetera. And so there's lots of different configuration changes that you can listen for. But what I've done is I've kind of boiled it down into 3 key areas that you guys should be thinking about and kind of looking at when it comes to handling these different types of configuration changes. And they are screen considerations, input considerations, and kind of how to build your APK and set it up in a way that it's going to be very adaptable across all these different devices. Now, different devices mean that there are certain configuration changes that will happen more often or maybe more important to handle and be aware of. But again, for the greatest baseline compatibility, which is what we suggest everybody goes for, you're going to have to kind of look at all of them. So that's a quick overview on configuration changes. Now let's kind of jump into what are some of the things, considerations you have around dealing with screen configuration changes while you're building out your game. So you've got a game, and on devices like Chromebooks and Samsung DeX, by default, your game is going to be launched in a windowed environment. So this means that you have a game window. It can be dynamically resized to different aspect ratios and resolutions. And this is by default. So this is much different than what you'd expect happening on a mobile device when your game gets launched. And now coming soon on devices like foldables, you've actually got a much different aspect ratio on the outer screen. And when you open up, the player can open up the game or the foldable at any point in time, and your resolution and aspect ratio are going to change yet again. So you guys have to be set up to handle that. Now, each one of these cases, as I said, is going to fire off an onConfigurationChanged event. So again, the key all comes back to handle these configuration changes and make sure that your game is set up to do so. So in this example, I've set up that I want to handle screen size and orientation configuration changes. So now, if somebody's playing my game and either one of those events happens, I'm going to get a callback to my onConfigurationChanged. And now I can scale my UI to match the new resolution. I can adjust my orientation. I can adjust my input areas, because if your screen resolution changes, now your touch input areas are going to change as well. So it's a pretty powerful function to be able to do whatever you need to do that suits your game and how you've built it, to be able to handle all these different things that might be happening at any point during gameplay. Now, if your game is always intended to be run in full screen, which for a lot of mobile developers and Android developers, they expect this, there is a way to lock your game to full screen. So in your manifest, you can just simply declare resizable activity equals false. And this will, by default, launch your game in a full screen, and it will not be resizable at all. However, we don't recommend that you do this, only as a last resort, or if you're trying to fix some bugs in the meantime. Because what it does is it limits the user experience on these windowed kind of environments. So for example, now they can't have like a chat application open or YouTube or something like that. And actually on mobile devices as well, it prevents it from running in split view mode. So as you'll see a little bit later in the deck, when I talk about foldables, this becomes even more of a limitation for the user if you don't allow your game to run or to be resizable. Orientation. So you should be thinking about the default orientation of the device you're running on. So on phones, it's portrait, but many other devices, it's not. It's landscape. And actually, a lot of these devices now we're seeing are convertibles. So Pixelbooks and other Chromebooks are a great example where they can switch from a clamshell landscape orientation to now portrait tablet mode. So it's really important to make sure that you, if you haven't already, specify the sensor orientations that your game supports. And so what this is going to do is it's going to tell the OS what orientations your game runs in, and you won't get into weird situations where if somebody flips the device into a different orientation, your game flips upside down, or it gets into some weird orientation change loop. And if you're handling it in code, make sure you're using display.getRotation, as this is going to get you the actual rotation of the device. But be aware that the rotation might be swapped to default values depending on what the default hardware orientation is. So just be aware of that. Now, another thing with foldables to think about now is aspect ratio becomes really important. So as you can see there on the outer screen, the aspect ratio is much longer. It's 21:9 to be exact. And so for supporting full screen on that outer screen, you kind of have three options to make sure your game is going to handle this correctly. The first is to target SDK 26 and above, which for a lot of you, if you're pushing updates, this is required by Google Play now. So that's the first option. Make sure you also set your resizable activity as true. So again, letting the system resize your application as it needs to be done. And now, if neither of those are an option for you, what you have to do then is specify a max aspect ratio inside your manifest. So this needs to be set underneath the application tag. 2.4 will handle values up to, will handle aspect ratios up to 21:9. So that ensures that your game will run on these kind of different aspect ratios. And of course, when you do this, make sure that your UI and everything behaves the way you would expect it to on these different aspect ratios. Now, I talked a little bit about split view, and on foldables, there's this new feature in Android P called multi-resume. So with these larger screens, there is this interesting use case that now you can have multiple activities up and running on the screen at the same time. Now, by default, as of Android P and earlier, if you had two activities running in split view mode, only the one that was last interacted with is going to be running in the on resume state. Everything else would either be in on start or on paused, which doesn't make a lot of sense because then you can't really play a game or interact with, have a chat like application update if you're not interacting with it. So now in P, there's this new feature called multi-resume, which means that if both the OEM and the game developer or application developer opt into this feature, now every top-level visible activity is going to be in the on-resume state. So essentially, this means that users can finally multitask on these larger screens, and they can have the game open with a chat application or whatever. So this, again, is really important that to tie it back to make sure your game does support use cases like this, because as more and more players pick up foldable devices, they're going to expect that something like this works. It'll be a disappointment to them if they download your game and they find out they can't utilize it. Now, to support multi-resume, it's super easy. Again, you just go in your manifest and you add this metadata in there. So now, if both the OEM and you have opted into multi-resume, you're going to support it. And for devices that don't yet support multi-resume, it'll run exactly as it does by default, where only the last activity that the user interacted with will be running in the on-resume state. So it's really easy to support it, and if the device does not support it, there's no risk there for you. Now, in general, with more pixels comes more flexibility as well with HUD and UI design. So if your players are playing on a larger screen, consider what UI elements they can add, expand, change, or adapt to suit that display. So they also tend to sit farther away from the screen, the larger that screen is. So make sure all your text and elements are readable and identifiable as well. And our friends over at Clay, the makers of Don't Starve, did a great job of handling this, where they actually give you the option of removing the virtual joystick and the touch buttons on the screen. And you can also scale the size of the UI and HUD to match what you would expect or whatever device you happen to be playing on. So it's a great example of giving users the choice of setting up to optimize for a certain screen size. So now let's talk about input. And input, I'm going to throw up this line again because input is a very, this is where this comes into play, because input is very volatile. At any point during your gameplay, a user can attach an input device, they could remove an input device, and so it really comes down to, again, trying to anticipate that you're going to get some kind of input hardware event, and being adaptive to what that is. And by being adaptive, that really means try to anticipate what the user might intend. So obviously, if somebody attaches a controller in the middle of gameplay, they probably want to use that controller. So your game should just naturally switch over to it. And not only doing that, but allowing users to choose what kind of input methods that they want to use. So you might find that there's a bunch of different input methods that are attached to the device your game is running on. You want to give players the choice of picking which one. So it all comes down, again, to it's not just a touchscreen. There could be a lot of other things attached to it as well that the users want to play with. So again, ties back to the configuration changes. And so here in this example, I'm setting up that I want to handle keyboard being attached or detached, and also if the keyboard becomes unusable. So that's that keyboard hidden flag right there. And where that comes into play is on things like Pixelbooks, you might have a keyboard that's available in the hardware when you're in clamshell mode, but when a user flips it into the tablet, the keyboard's on the back side and is no longer usable. So it's important to also not forget about the keyboard hidden configuration events as well. And now, a way to kind of approach, right, this volatility of all these different input methods, what I've kind of done here is, as an example, right, trying to detect maybe at game startup or during my on-configuration change loop, trying to detect all the devices that are available for me to control the game. So I can use Input Manager here to kind of loop through all the hardware and figure out what input devices are attached to this particular device. And then once I do that, I can loop through and kind of maybe check out and see, is there a mouse attached? Is there a keyboard attached? Is the keyboard usable? And it comes down to trying to assess the state of all the input devices that are currently available. And then in this case, if I detect that I have a mouse and I have a keyboard and it's usable, I now switch my control scheme over to desktop mode, right? So I've got WASD and maybe mouse to click or something like that. So it comes down to kind of trying to figure out what's available to you and what the user might want to use. And this also ties in with what is your gameplay, right? So obviously for a first-person shooter type gameplay, mouse control is going to be more important. If you've got a third-person camera, maybe use the mouse to control that, or you're using WASD to control the player movement. So adapt it, not only adapt it for your game as well, right? Different gameplay, different things are going to make sense. So Asphalt 9, Gameloft did a great job of this with Asphalt 9 and Asphalt 8, where basically at any point during gameplay, if somebody attaches a new input device, like a game controller, it just seamlessly pauses the game. It pops up a new dialog that shows the user, OK, here's all the buttons you need to press for an actual controller. And throughout the entire game, they change all of their text and kind of visual textures to show that new input method, whatever the primary input method is. And on top of that, they also let the users go into the options at any point in time and adjust what control method they want to use. So it's a great example, and I recommend you check it out, of, again, being adaptive and anticipating those changes. And for a lot of you that make mobile games, you might not think that keyboard support makes a lot of sense for your type of game. And I would ask you maybe, though, to consider that when you add in keyboard support, you improve the accessibility of your game. So you can do things like skill key bindings, WASD for character movement, menu navigation. If you really want to get fancy, you could also let players map specific buttons to in-game actions so they can set it up to play exactly how they want. And don't forget about mouse capture. So this was added in Android O, this mouse capture API, and it's very, very frustrating when I boot up a first-person shooter or something else, and I try to use the mouse, and it does not work. So it's really easy to just request pointer capture. It locks the cursor to the center of the screen. You can get your motion vectors from your mouse, and then if you want, at some point, you can release pointer capture to go back to standard mouse control. So it really, really makes a huge difference and makes games infinitely more playable when you're playing on something like a Pixelbook in laptop mode, if you can use the mouse and it works. Game controllers. Now, game controllers have been around for a long time on Android, and there's been game controller APIs with varying levels of game controller support from developers. So there's more and more game controllers that are being launched for Android, and as we see kind of these new devices that are running Android, there's a growing interest in players being able to pick up some kind of Bluetooth-enabled controller, sitting on their couch, and playing on a larger display device. So consider adding in game controller support because it's becoming more and more prevalent. So we've talked about screen considerations and we've talked about input considerations. Now I want to talk about some general considerations around building and setting up your APK in a way to make sure it supports all these various devices running Android. So first off, you should review your permissions that you're asking for. And not only your permissions, but your features. So not all features are supported across all these different devices. And if you're blindly asking for a certain feature that's not available, somebody's going to come along in the Play Store, excited to play your game. They're going to try to download it, and it's going to say, this game is not supported on this device, which is not a win for anybody. So what I recommend you do is you list them as not required in your manifest unless you absolutely need them. And then in your code, just check for the availability at runtime. And if they're not available, just handle it gracefully if you can. So again, being adaptive to the device you're running on. So good examples of features that are not supported on all of these devices are things like GPS, SMS, even something like the back-facing camera is not present on a lot of Chromebooks. So if you ask for these or need them for certain features, you won't be able to download on those devices. Now, you should also consider the hardware profile that your game could be running on, right? So I know a lot of game developers either have some kind of quality profiles set up for different device classes or performance levels. And some developers actually implement, kind of runtime automatic quality control detection system that's seeing what your frame rate is and trying to adjust things like draw count and stuff like that on the fly. It's really important to either test the automatic quality control software you might be running, or to add quality profiles set up for these new range of devices, right? So if you've got a gaming focused Chromebook that comes out, or something like that that has a lot more CPU and GPU performance potential, try to create profiles or make sure your game handles a case of running on this higher end systems and looks great on these larger screens. Additionally, try to provide an x86 build if you can. So a lot of Chrome OS devices are Intel only, and while your ARM binaries will still run, you might incur some overhead with the instruction translation that's happening. So try to provide an x86 version of your native libraries if you can. I'm going to talk about Android app bundles in a little bit, which is a great tool to make this a lot easier to support rather than just inside your APK along with your ARM binaries. And if you're going for the most graphical performance, lots of these devices now support Vulkan. And Vulkan is reached a point where we're seeing lots of gains from developers that are choosing to use it in terms of maximizing their battery performance and their graphical performance as well. So consider moving over to Vulkan if you're really going for that high fidelity type gameplay. And finally, test across all these devices. So add test cases that cover things like resizing, minimizing, maximizing, switching from the smaller screen to the larger inner screen. I know that you might not have all these devices or have the resources available to have the actual physical devices to test on. So use things like the Android or Chrome OS emulator to test on. Samsung has released a foldable emulator that works on Android Studio as well. So just try to boot up your game in one of those if you don't have the actual device and see how it behaves. And doing that, you're going to be able to get a great idea of if you have any major problems right out of the gate. Also, you can use something like Firebase Test Lab to help automate the process as well, which has all these different kinds of devices inside of it. And in the spirit of using the tools that are available for these different devices, Chrome OS specifically has a performance tool they just announced here at I/O that if you are looking at developing for Chrome OS, I highly recommend you take a look at it, as it shows you, it's kind of like systrace if you use that, where it shows you how the desktop is being composited, when the memory swapping is occurring, CPU, GPU frequencies, and so on. So highly recommend you use the tools available for the specific devices if they exist. And if there's a tool that you guys would like to see that's not available, let us know somehow, and we will do our best to try to accommodate that. Now, I kind of mentioned Android app bundles. And for those of you, to tie it back to what I said about you can do this with one APK, right? Well, you can do it with one APK, or you can do it with one Android app bundle. And Android app bundles are essentially a new way of distribution on the Google Play Store, where it saves you from having to manage multiple APKs or trying to fit everything inside of a single APK and staying underneath the Play Store size requirements for your base APK. So instead of uploading an APK to Google Play, what you do is you put everything, all your native libraries, all your different screen density resolution assets, all your localization files into an app bundle, and you upload that to Google Play. And now what Google Play is going to do is when somebody comes along on, let's say, high-resolution x86 device, it's going to generate and sign and give them an optimized APK that only contains the x86 and high-resolution assets, so they get a smaller download size, and they don't get all this extra stuff that they don't need to run the game. Now, some of you might be aware of on the Play Store that there's a 100 megabyte limit for your APK. If you go over that amount, you have to use expansion files. If you use app bundles, that limit is actually increased to 150 megabytes. So we're really recommending, this is what we feel is the future of distribution on the Play Store and Android in general. So we've been recommending to all developers, and especially game developers that have a lot of assets and different sets of libraries, we recommend you guys try to switch over to app bundles if you can, as quickly as possible. And luckily, it's pretty easy to do. I talked about that. If you're using Unity 2018.3 and above, you can simply just choose to build an app bundle instead of an APK. Or if you're using Android Studio 3.2 and above, you can simply, again, choose to build an app bundle instead of an APK. And then once you build that app bundle, you just upload it straight to the Google Play Store. Now, if you have a custom build pipeline or something like that, you can use a great tool called bundletool to generate an app bundle from the command line. And another useful feature of bundletool is that not only will it generate an app bundle for you to use, it'll also let you generate test APKs from that app bundle. So let's say you build your app bundle, and now you can generate specific APKs for different device configurations and hand that off to your QA team or to your automated testing solution, such that you get all the benefits of this app bundle, smaller download sizes, but you don't have any of the overhead of trying to also generate APKs to fit into your existing testing processes. So it's a great tool, and I recommend you guys check it out. OK, so talked about a lot of different things today, and obviously there's a lot more we could talk about. But what I really want to stress to you guys again is that Android gaming is not just phones anymore. Players are experiencing, whether you know about it or not, or like it or not, they are experiencing your game across a wide variety of devices. And by following some of these best practices that I've talked about, so thinking about the screen, input, setting up your APK in a smart way, you're going to cover all these additional use cases and get the best possible gaming experience for your players, no matter what device they happen to be playing on. And if there's one thing that you take away, we talked a lot about different technical points. I want to stress that if you start off just by changing your mindset about what kind of device you're building for, in the sense that you're not making any assumptions about its capabilities or what input devices or input methods it might have attached to it, just change your mindset and try to build something that's adaptive as possible, either in your next game engine or your next game that you happen to be building. And if you start off just by spending a little bit of time thinking about these additional use cases, it's going to make your life a lot easier, and you're already going to get 99% of the way there. So I wanted to call out, if you're very interested in maybe having your game looked at and seeing how it might function on these different devices, or any other technical questions you might have, we're actually doing game reviews in the garage back there. So highly recommend you guys stop by and check it out. You can just go through the doors over there in the back corner. There's a walk-up desk. Either myself or one of my esteemed colleagues can sit down and talk with you guys about any kind of technical issues you might be having. And that's it. I hope you guys found this talk informational and exciting, and I hope a lot more of you consider all these different devices as you continue to build out your games. And thank you so much, and I hope you have a great rest of the I/O. Thanks.